So thank you. And my name is Alessio Soldano. I'm an associate manager at Red Hat, and I lead and manage those that work on the RESTEasy project, which is an implementation of the JAX-RS API, which are Java API for web services, REST services in Java. And today I'm going to talk to you about some recent additions that we have done in RESTEasy to better support reactive programming and asynchronous in general. So let's first clear what is RESTEasy and why I'm talking about it here today. So RESTEasy is a community project of JBoss Red Hat, and you can read everything about it at resteasy.jboss.org. The sources are on GitHub. And as I said, it mainly implements the JAX-RS API, which used to be one of the APIs defining the Java EE specification suite, defined by the JCP, Java Community Process, and which recently have been transferred to the Eclipse Foundation under the Jakarta EE name. And as I said, it is a community project which end up being integrated into the Wildfly application server. And Red Hat actually productizes that application server, which implements the Java EE specification suite, and it turns it into one of its products, actually one of its main products, which is the Red Hat Enterprise Application Platform. RESTEasy and being used in that product, but it is also used in many other products of Red Hat as well. And it is a framework for REST services in Java, not just an implementation of JAX-RS API, but of course implementing the API is one of its main concerns. So today we are going to talk about reactive programming and what we did to move beyond what's in the JAX-RS API. If you've been following the evolution of the JAX-RS API spec, you probably know that in its first version, which is the 1.0, which was the 1.0, everything was expected to be blocking. So a basic resource would have been defined, as you can see here. And here you see that we just have a POJO object annotated with @path, and a resource method classic annotated with @path and @get. Of course, there are many other annotations for different types of invocations and so on. And what would be happening is that this method would simply return is answer by running in the same IO thread that is serving the request. No real problem unless you end up concatenating different services and invoking another service within this service. As a matter of fact, in the second version of the spec, JAX-RS 2.0, the client API also got specified. So by using the API, a user could actually concatenate services by having a client run within the server, as you can see in the resource below there. And here the problem is what I mentioned before. So an invoker of the service resource would have to wait for both the IO of the first invocation and the second invocation to the previous resource that I've shown you in the previous slide. And this, of course, can become a problem, especially if you think about these days we are talking about microservices and things like that. And so the problem becomes more and more important. Expecting this type of issues, still in JAX-RS 2.0, we got the chance of having asynchronous invocations, asynchronous execution of resource methods, and that was supposed to be done by using the @suspended annotation on an async response parameter to the resource method. And that would have and still suspend execution on the IO thread and allows you to perform heavy computations on a different thread, and then you can resume the execution on the original thread and let the response flow to the client. In the example here, we simply create a new thread and we mimic the heavy computation by doing a sleep. But of course, in a real-world scenario, we would have a pool of threads that can be used for doing some heavy computations or stuff like that. And at the end, the response is resumed and returned. The async response object is resumed, and the response is sent back to the client. On client side, still JAX-RS 2.0 allowed us to do asynchronous invocation as well. We got an async method on the invocation builder, which is returned by the web target on client side. And you can see it in the middle of the slide there. And that async method basically returned to the client an async invoker, which was a slightly modified version of the usual invoker that had a get method accepting an invocation callback. And the invocation callback could be used to get notified of the response having been received or an error having been received. The get method would have returned a future, which might seem as an interesting response type, but actually it's not of that use when you end up composing multiple client invocations, because of course when you do feature.get, you basically end up back into synchronous and blocking mode. So in any case, with this API, you could compose a client and server's invocation as shown in this example, and in a pretty decent way. The problem is that when the complexity grows higher, you have problems because of all the invocations called back that end up piling one on top of the other, and basically turns the code into a completely unreadable and unmaintainable thing. This is what is usually called invocation callback. And to solve this and try moving forward towards the more modern reactive approach, in the JAX-RS 2.1 specification, which is the latest available so far, and which is being completed in end of summer last year, we have seen that support for completion stage has been added. So you can have a resource method that returns a completion stage. So for instance, you could instantiate a new completable future and then return that straight away. Of course, the completable future would then be actually completed after the heavy computation that you are expected to do. And then the runtime would automatically suspend execution as if you were using the @suspended annotation on client. On client side, similarly to the async methods that we mentioned before, two new methods, RX and RX with class parameter, have been added on the invocation builder. And the return type when you use this RX method is not future anymore, but it is completion stage. Completion stage of the type that you actually are expected to get from the client invocation. The advantages of the main advantage of doing like this is that, of course, you get to use the richer API of completion stage, so you can easily compose invocations of different services and write a better code that is more easily maintainable. However, so that's the only thing that has been added to the specification, which is probably not that much if you want to achieve a real reactive programming integration with the REST APIs. But fortunately, in doing this, those that actually define the newest version of the API spec allowed a way to extend the solutions available by implementing two new interfaces that are RX provider and RX invoker and RX invoker provider. So basically, you can plug in an implementation of those API interfaces that allow you returning different types. And what matters to us is that you could return reactive types, for example, from RX Java or RX Java 2. And we did that in RESTEasy. We actually created two new modules, which are RESTEasy RX Java and RESTEasy RX Java 2. And in those, we implemented the RX provider interface to RX invoker interface to return a single, which is one of the types of reactive Java, the most simple promise-like type. That way, you can create a client and run it the way it is shown in the slide at the bottom of it. And you see that we directly get a single of string as a return, as a result of a REST client invocation by simply telling the RESTEasy container that we want to use this single RX invoker class. So far so good. This is on client side. Unfortunately, on server side, there is no pluggability system available in the API. And we really wanted to have a solution that allowed us to extend the API both on client and server side. So we decided to go our own proprietary way, and we created a new interface, which is a sync response provider for the server side too. And this is similar, a similar concept to the one that the API defines on client side. And it has a single method, which is toCompletionStage, which accepts an instance of any class and return a completion stage of that type. This way, of course, we have the straightforward implementation that allows implementing the specification that is returning a completion stage. But we also have another implementation that returns a single, which is called clearly single provider. And the implementation is part of RESTEasy, so by using RESTEasy you get it automatically, but of course you could define similarly your own provider by annotating it with the JAX-RS @provider annotation and including it into your deployment. Anyway, this way you can define a REST resource the way you see here in the example, and you see that the RX resource method here returns a single directly without any special treatment, and the container internally automatically suspends execution when the method execution starts, and it allows the code to create the single, and when the value in the single is really available, the response is created and sent back to the client. Of course, the thread is resumed and so on, as if in an async execution. Putting these all together, we can do the concatenation and composition things that we have seen before. And you see here, we can really use RX Java within our own REST resource implementation. So you see, with the single, we can call the map method. And basically, we can use the full API and simply return the single as if it were any other type of object. Things becomes a little bit more complicated when you have to deal with streams. As you most probably know, reactive objects can hold multiple types, not just one type that is made available asynchronously. And these values could also be unlimited in number. So to deal with this type of values, with a lot of values, usually streams are used. And Red Hat, together with many other vendors, contributed to the Reactive Streams initiative, which aims at defining a common API for reactive streams. And actually, the API from this initiative have been actually used and implemented by some existing technologies, like the second version of RX Java. And And so we decided again to provide out-of-the-box an implementation of the a support of both the RxJava and RxJava2 streams, so observable and flowable. You know that flowable is basically an enhancement of the observable that allows back pressures handling. So a mechanism for the server to control the pace of the data that came from the client. So if the server is somehow overloaded, it has a chance to control the speed of the data that's coming to it from the client. So what did we do? Similarly to the async response provider that we've seen before, we have defined yet another interface, which is async stream provider, which again has just a single method that is to async stream and returns a publisher. The user is free to implement this interface. Again, put the implementation into the deployment and use it directly. Otherwise, it can rely on 3 implementations that are available out of the box in RESTEasy, and that provides support for Flowable, Observable, and the Simple Publisher API. Clearly, the names are Flowable, Observable, and Publisher Provider. And on client side, given we already have the extension point available from the JAX-RS API, we reused that, and we extended the available Rx invoker annotation to create our observable and flowable Rx invoker. You can see that the flowable one has the methods for dealing with the back pressure strategy. Again, implementation of these interfaces are provided out of the box by RESTEasy, but can also be provided by the user deployments. And you register them on the client the way you register any other JAX-RS providers. And once you have all these available, which means, for instance, just running with RESTEasy on your class path or in your module system, you can eventually write a resource like this. And you see that this resource returns a flowable of a list of strings. And the flowable is created within the resource. And upon its subscription of such a flowable, 2 lists of 3 elements are created. And after the creation of each single list, the list is sent back through the emitter. And so the client is expected to start receiving it. This actually depends on the way that you annotate the resource. In this case, you see that there is a NetStream annotation, which we will see the details about in a few minutes. And what happens is that RESTEasy automatically subscribe the flowable that's created within the resource. Of course, it suspends the execution on the incoming on the thread that deals with the incoming message. And as soon as the lists are pushed on the emitter, the response is sent back to the client, which start receiving the stream straight away. On client side, again, we have support for the flowable, and you can see that you just have to use the flowable Rx invoker that we mentioned before as a parameter to the Rx method on the invocation builder. And then you get back the flowable of list of strings, and clearly you can use the API of flowable from RxJava2. So you can use, first of all, you need to subscribe to it. In this case, there's no automatic subscription. You control it, and then you can do whatever you want with that data as it comes available. And in the example here, the thing list would end up being the list that you see below, so a list with 2 lists of 3 elements each. And you see, you really have a chance to plug this together with your application that uses reactive programming. As I said before, we added a NetStream annotation, and that's used to control the way the data is actually marshaled on the wire. You might wonder how a reactive stream is actually going on the wire for a JAX-RS invocation. And the way that, that we decided to do is to allow the user to control that. If there's no AddStream annotation, RESTEasy would basically treat the stream as a finite stream that has to be transformed into a collection. So in the case before, a list would have to be created, and once the list is completed, it is returned, of course, asynchronously to the client. So in the example below, you see a JSON message would have and being sent to the client, sent back to the client, and you can see how it looks. But of course, you could have used the AddStream annotation, and with the default behavior, the AddStream annotation, the default is stream mode general. The treatment of the stream is the same that you get with the SSE protocol. Another addition that came with JAX-RS 2.1 is support for SSE, which stands for ServerSent Events, which is a technology from W3C that allows client getting back events from event sources on server side. And the fact is that getting data from a stream is really similar to getting events from an SSE source. So we decided to make these things work similarly. And so by default, if you add the AddStream annotation, you get the same messages that you would get from an SSE source. So you can see the data in the beginning of the messages. And the content type is the same of SSE, so application XStream general, with an element type that is controlled by the addProduce annotation, which is a JAX-RS annotation, of course. Below, you see an example of such a scenario. There's yet another configuration that you could use, which is AddStream with raw mode. And if you select this option, you don't get an SSE-like behavior. Instead, you get a raw behavior, which means that the data is returned directly on the stream as soon as it is available, with no transformation, no padding, no whatever. And the streaming, and the content type is directly controlled by the addProduce annotation. And you have an option for explicitly telling the client that the stream is unbounded, because clients sometimes might perform different choices, implementation choices, depending on the stream being unlimited or not. Think about memory allocation. If you know that you are dealing with an unbounded stream, you shouldn't be keeping on allocating memory for each message you get, and you should eventually free the memory. And of course, this mode is really suitable to arrays, to byte streams. You can see an example here below. Still, speaking of streaming, it is important to know that clearly we are talking about distributed systems, and the client and the server are fundamentally disconnected. So the advantage that comes from an implementation like the one I've shown you so far is that you could use reactive programming on one side and not on the other. So for instance, you could have Flowable used on server and plain lists on client, or the opposite, which simplifies the migration to new approaches. And similarly, you have full SSE interoperability. So if you have an SSE source on server, you can consume the messages that come using reactive programming, and you can of course do the opposite. Maybe you have a server on which you are using the RX Java 2 APIs, and you can consume what comes out of that through an SSC sync on client side. And then there's another interesting thing, which is actually a proprietary feature of RESTEasy, which kind of got copied within the microprofile REST client API recently, which is the RESTEasy proxy. So you might know that with RESTEasy, you can define an API, an interface on client side for the resource that you are invoking, and then you can build a proxy on client side from such an API, from such an interface, and they invoke directly the methods on that proxy instead of using the JAX-RS get, post, or whatever methods. And by having an ancient the client to support reactive methods, we can do the same also on the proxy. So we can have the proxy interface that has a method that returns, let's say, a flowable or any other reactive type, and we can use that directly, seamlessly, without having to bother about what's happening under the hood. And this makes creating a client as simple as you can see in the example below. So proxy get flowable ends up invoking the get flowable method in the interface, in the implementation of the interface that you can see up there. Besides for these RX Java additions that I've mentioned so far, we have also added a few other things related to asynchronous that helps you getting rid of any part of your JAX-RS application that implies a blocking behavior. And the first addition, besides what we have seen so far, is the support for asynchronous containers filters. So filters are a concept from JAX-RS. Containers filters are objects that can be used to perform some computation over the message that's coming in towards the container and that's coming out as a response, exactly just before and just after the business method execution. And the problem is that those filters are, of course, blocking. So if you perform any computation in there, of course, you end up delaying the execution of the business method, even if the business method is expected to be asynchronous afterwards. The request container filter would run before the request is actually suspended. As a matter of fact, it became useful to allow making those objects asynchronous too. So what we did to support that is that basically one of the parameters that you get within the filter method of each filters is the context, and you can simply cast the context, which is an interface from the API, to the suspendable container request context or suspendable container response context, which are interfaces from RESTEasy. And those interfaces come with 4 methods that are suspend, abort with, resume, and resume withdrawable. And you can use those methods to basically turn the request into asynchronous mode. So you can suspend the execution, do whatever computation you need, and eventually resume the execution. And the interesting thing is that by doing that, the whole execution after that is turned asynchronous. So even if the methods, the resource methods, is not asynchronous, it ends up being asynchronous, and without you having to change any single line of code in the resource method or in another filter that runs after the filters in which you're doing this thing. So it is completely transparent to any other part of the JAX-RS application. Another addition that we did is allowing turning the injection to asynchronous mode too. That means that if you rely on request method parameters to be injected before the actual resource method is executed, you can tell the container that you want a synchronous injection, which means the actual execution of the resource method happens just after the data is available for the injected elements. And before that, the request is immediately suspended. And this is achieved by implementing yet another interface, which is context injector, which of course has still to be at provider annotated as any other provider. And the wrapper type that you can see in the interface here has to be an asynchronous type, so completion stage, publisher, flowable, and so on, single. And here you can see an example. You can see that, well, we have defined a Redis query interface annotation. The example here is about fetching some data from Redis before actually executing our resource method. And we have defined the annotation Redis query, which is meant to provide a container with the query that you want to be run for fetching the data. And then we have a Redis injector that implements the interface that I mentioned before. And within its resolve method, we get the context from RESTEasy, and from that context we get the Redis client. We check if the annotation is there, and if the annotation is there, we ask the Redis client to perform the query that we need. Clearly, that returns an asynchronous value, and once the value is available, the Redis injector will return the value to the client. In this case, it is a single to the container, not to the client. And then below, you see the resource that uses this. You see that we have three parameters, RIC 1, 2, and 3. All of them are annotated with @Redis query and @context, of course, because they need to be injected. And the container runs asynchronously the three queries on Redis in parallel. And once all of them are available, the resource method is actually executed. Clearly, there are scenarios and situations in which this can be of help and improve the performances. Another topic that we have worked a little bit about is Nonblocking IO. So you probably know that there are basically different HTTP clients available as open source, as Java open source implementations, and RESTEasy has a pluggability system that allows you to use different implementation of the HTTP client for its RESTEasy client. By default, the HTTP client from Apache is used under the hood, and with the recent version of RESTEasy, we've added an option for automatically pulling the Apache HTTP async client, which uses an IO under the hood, and it comes by default with a standard configuration that uses, I don't remember how many threads for dealing with the IO, but clearly you can configure that. And the interesting thing is that once you set up the client, you basically can use the RESTEasy, when you set up the engine, you can use the RESTEasy client as if you were using any other HTTP engine. So here is an example. You see that we get the client builder, which is a JAX-RS API class, and we cast it to RESTEasy client builder. Clearly, this is going to work if you are using RESTEasy, otherwise you would get a class cast exception. And once we do that, you can call the use async HTTP engine methods, which tells the client to use the async HTTP client engine. Here, we could also use another method, which is .engine, and in there we could basically tune all the details of the underlying HTTP engine. And once we do that, we simply perform the invocation as if we were doing with a plain and standard JAX-RS client. In this case, we are doing an async invocation, which clearly is the type of invocation that is going to benefit most from NIO usage. And we have an invocation callback that simply performs an assertion over the response that is received. And that's all. So I think we are out of time of quite a lot. Maybe it's because I was prepared to do this in Italian, so I was fearing to be late with the English. So if you have any questions, I'm here, just ask. Thank you.
So if you have an interface that is blocking behind the scene, so instead of having a web client that can do things asynchronously, what's the best approach that you can think of?
Well, of course, you get the best benefits when everything is non-blocking, and that's also the reason why we kept on adding new features to turn whatever was left as blocking into non-blocking things. There are still things that need to be fixed, but still, the more pieces that you can change and turn into non-blocking, the better result you get. So clearly, if you know that you would end up at a given point with a blocking thing, you know that you wouldn't get the best performances out of that. So maybe you could start with changing something and then keeping on fixing things. But if you already foresee that you are not going to do anything with that, maybe you just go with the simple blocking approach.
I mean, the concrete example would be GDBC, basically. So maybe having a small, maybe in-house extension to do pagination behind the scene and stuff.
Well, of course, you need to be creative. Maybe you can hide that behind an asynchronous service and perform multiple invocations at the same time and deal with, mitigate the problem.
Otherwise, the back pressure thing, it's not going to work.
Thank you.
Hello. I've seen the code used quite a lot, this countdown latch.
Mm-hmm.
So isn't this making it blocking or like a promise get equivalent to that?
Sorry, can you say it again? The countdown latch there was used as an example to be in the test there to let me show it again.
Yeah, it's also here.
Here, it was just to be sure that we could wait till all the tests are executed, because I kept the code here from a test, actually a JUnit test that was verifying that all messages were received. So it's just for test reasons.
And how can you chain this completed request? Like if you have a chain of promises that similar to that?
Well, of course, you could use the other approach that I mentioned before, the reactive thing. So you could concatenate this with other reactive objects that you already have, and it's really up to the way your application is written. I don't know if that answers your question.
A bit. I'm just curious, how would you go on from here to avoid callback hell in this example?
My point is that you could even not use a callback. You could use an approach like what we have seen before. Let me find a slide that makes sense for this. This is about streams. You could use a thing like this. The changes that we have seen in the last slide are about the way you create the client. and then the client is used the same as in all the other examples. So here you have no callbacks, and you can get reactive types out of the invocation. And with the addition that I mentioned in the last slide, the client will use non-blocking IO under the hood instead of the blocking client. That's the point of the changes.
Okay, thanks.
Does this also support like bidirectional asynchronous communication, like for WebSocket, for instance?
No. Basically, the fact is that in this case, the Apache HTTP async client is used. Actually, you could implement the HTTP engine interfaces of RESTEasy with another low-level client. I think that someone else did that for Undertow, for instance, but we also have implementation using Jetty, and I think someone did that with well, there's an implementation that uses, of course, the your connection from the JDK, and so basically you could implement this with something different that has the feature that you need. So WebSockets, for instance.
Not
no, it doesn't come by default. No, of course it's not part of the spec, and there's no default implementation, at least provided by us. But
because it will be the argument of the endpoint that you don't get it as blocking. So sometimes you get a request and you need to react to that request, and the connection remains open, basically.
Well, how about you propose an addition?
No, Play Framework has it since 8 years ago.
Yeah, I mean, we can create a feature request. I mean, and work on it.
Thank you.
Well, seriously, feel free to propose that. I mean. Okay, so thanks for the questions.